Okay, this is a little better. We can deal with this. Now I don't have that stupid vertical bullshit going on. Yeah, I couldn't figure out a way to get rid of that. Anyway, so NeoPixels, your lighting. What are you doing?
Nothing,
Why not?
because I don't feel like it right now.
Oh no, I'm talking about planned and shit like that. I'm not telling you to do it right now. Fuck. That's just stupid. Where's your Python at? I'm not talking about the penis in your pants.
I knew what you meant. It's saved on a drive.
No, I mean, where are you with the programming on it?
I'm just
Have you got
working, just that example code for
okay?
from the Adafruit website.
Okay, still playing with that. That's cool.
Yeah, because if I have to use that as the basis for how I need to create the program itself, I mean, it's not overly complicated. It's just there's a lot of shit that I don't understand yet.
Right. Um, and that of course ties in with the WLED.
Well, WLED is kind of the cheating route because it's got all of those preloaded animations already in it, so you just need to control it through your phone or whatever device that you're going to be connecting to the lights with, and you tell it, all right, switch to this one or this one or this one, or you can make your
Right.
own in there.
Right. But it goes a lot further than that, and you probably haven't dug deep enough into it.
No, because I wasn't planning on using WLED anyways.
Honestly, I think I am just because it's the quicker route. But you're right. If you want it to be truly yours, you need to write the code. Once you get further into the Python, you'll find out that that sucks. That's what I'm finding out. In fact, I got a recalcitrant fucking W. Well, it's not a W, it's an ESP32 that's being a bitch. Not sure what's going on with that damn thing. Cheap Chinese shit. Anyway, it's my little temperature monitor thing. It likes to blink out. Piece of shit. I think we lost Sean when I reset everything.
And we're probably going to lose a lot of things.
Well, we only had Sean and you and I, so yeah, we didn't lose a lot. Poor Sean. He's probably like, "What'd you bug, man?" Either there he got a service call. Anyway, so I guess my question is, you figured out he had how many pixels?
924,
Okay, so
approximately.
I've got 125 with my cube. No, 120. It's 5 by 5 by 5. 125. That's right. And yours, you're not really doing a three-dimensional, you're doing a string, right?
Yeah, it's just a single string of lights.
Okay. So when you do a 3-dimensional one, you have to take that into account to the animations. So, give you an idea here. This is the cube. Number 1 is right there. That's number 1. And then it travels around, but I'm not sure. I think it's a snake path. So it probably goes meh, 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 and then it goes up and does the same thing. Probably in the reverse order. That's where I'm at. So it's kind of a bitch. Whereas if you're doing a single string, then it's like strobe effect, and you can get certain areas of it to light up just by the pixel number. And I can do that with cube too, but the programming treats this as a string, even though it's
Yeah.
3-dimensional. So now I'm making you think. That's why I wanted to pick your brain on what you got going.
Well, if they're just connected in sequence, or I should
Mhm.
say in series, it's just treating it as one long string that is just stretched out over a large surface area, then
Right.
it
And
shouldn't be that difficult because you're gonna just create your protocol and it's
mhm,
just gonna enforce the protocol.
right.
You're just
But
gonna have to tweak it.
that's where the programming comes in, is because yeah, you can treat it as a string, a continuous string, but now you're in 3-dimensional space, so you have to think about what pixel is at what point. That's why I was trying to pick your brain about what are you using, because there's WLED is really good for that for the most part. I think they have a 3-dimensional grid thing that you can use. When I first started playing with this, I was using a shift register and something like this that I put together myself. So you've got a grid of all these LEDs, but now you have to turn them on at certain times and you have to be able to power all of them. The NeoPixel fixes all of that and gives you the ability to control them internally. These are dumb LEDs. You know how many of these I burn out? Fuck that shit. It gets pretty expensive pretty quickly. I think about half of those LEDs are dead. I've got a green one that's the same way that I put together, I think, on a little larger grid because I was using larger LEDs. But yeah. And then you try to stack it. I'm
Yeah.
testing your metal here, buddy. Finding out how much electronic ability you actually have.
I don't have shit.
Yeah, you got more than you think. You just haven't been
Um,
challenged. So here's the rundown. Sean, come back. Nah, he ain't come back. You don't like us no more. You gotta give him a shout. Anyway, um, it's not looking like I'm going to be employed very much longer.
Mm.
After what they did today. I'm the guy that keeps everybody working, but they couldn't get anybody to come in, and I had to go out and work, which is fine. And then I found out the engineering is so bad, that's the reason that we're so far behind. So all my underlings have no abilities, and my supervisor's leaning on me like a bitch. Yeah, I'm not real happy about it. Luckily, the big boss stayed away from me. The big boss, the director guy, because I'd have probably had him in a headlock and started punching him in the ass. Um, my supervisor's boss, he's in the same boat as I am. He's like, this is stupid. Anyway, yeah. Plus, I have a christening to attend in Spain in March for my godson with my girlfriend from Colombia, and I'm trying to coordinate all of that shit. Yeah, life's grand. Gotta love it. Oh, and I made my mother-in-law's, who is not my mother-in-law, because I haven't been married to the girlfriend, but she calls me Mijo, so I'm son. Got her a new sewing machine today.
Sewing
Delivered.
machine.
Yeah, sewing machine. She's a seamstress. It's an industrial singer. They call it semi-industrial, but it's a light heavy duty, if you will. And there was much screaming and now I've got to see some results. The fucking thing cost me $320, I think, which isn't bad. Replace the one that her grandmother gave her. My mother-in-law is a year or two older than I am. Yeah, I know. Robbing the cradle. Her daughter's 40. And I'm 52. Anyway.
I'm just looking at a Flipper Zero.
Oh, dude. The Marauder's better.
I mean, it's a cool little hacking device.
Well, the Flipper Zero, you got to buy the hardware. You can't build your own. The Marauder, you can build your own.
This thing is whole. Like, it's the whole thing.
Yeah, it's everything. And you know all it is a pen tester.
Yeah. Oh.
And if you don't know what pen testing is, then you shouldn't be playing with it anyway.
I know what it is. It's basically testing the security of local networks, anything within
Mm-hmm.
range. And pen test is penetration test. That's what that
Mm-hmm.
stands for.
And you better be doing it with permission if you're doing it on anything but your network. That's what I'm getting at.
Yeah, just like if you were to do butt testing.
Mm-hmm. Yeah, if she don't want it there, don't put it there. Actually, don't put it there anyway because
No, because if you do, she's gonna have to yell back blast area clear before you pull out.
or Brother, no. Ew.
Yeah, that's how you get a urinary tract infection.
Yeah, you'll definitely get that.
Hell, you might just die.
That's possible. She might too, if you penetrate her colon and perforate it.
Yeah.
Yeah, I'm not interested in that shit. Literally. Change that fucking picture, man. That thing is nasty. Nah, do better than that. No. No. Let's do a jackal picture. That's fine. There could be better.
I don't think I want it to be better. That would be a bad idea. Not like that.
Oh, this is fine. You can do whatever they want with that.
It looks Hispanic, which is not good.
She's definitely Hispanic. But, that's not what I'm talking about either, because this is not a chick channel.
No, not really.
Fancy lights. By the way, have you even powered up your shit?
No, I haven't gotten a power source for them.
Mm.
They're 5 volt. I've got a 20. I got a 12 volt test strip, and it's like, I don't know, 30 LEDs per meter, or maybe less than that.
Buck converter. You can take this with your 12-volt source and use it as a tap on each of them. The big thing is with your lights, they have to be the common ground. And that's for the data set or the data side. So you can use one of these little modules. This one, I don't remember if this is the buck converter or if this is the up converter. I think this is the one that'll do any of them. I've got a different one too. But they got a bunch of shit on them that drops the voltage down or raises the voltage up. Buck converter drops it down. So your 12-volt supply, you can reduce it to the 5-volt. And then you want to reference your 5-volt for the control also. The control, the data line has to be 5-volt, the same as your feed voltage to the NeoPixels. Reason for that is they all work on 5-volt logic, but most of your new microcontrollers work on 3.3 volts. So if you're not running off a battery voltage, which automatically is lower than 3.3, it'll cause inconsistencies and bullshit. So with your 12-volt supply, what's your amperage on it?
Let me see. Uh, Where's the damn thing? What is this? Looks like half an amp.
That isn't enough to be useful at all. 500 milliamps?
Well, that's the output number that they put on this thing.
That isn't going to power those lights. What the hell did you pay for that?
I didn't pay for it.
Oh, okay. All right, good. Yeah, it was good. Oh my god. Especially because you've been asking about what kind of power supply do I need? Oh.
No, I'm thinking one of those BTF lighting power supplies will do just fine.
Possible. You can use PC power supplies too, like an ATX power supply. You just got to have a feedback on certain rails.
Right.
To
That's
make.
what's going to take up more space in this enclosure that I want to put all of this in.
Mm-hmm. Yeah, dude, you're not going to be able to power that many lights without injection on string, of course.
No, because it's 50 and a half feet of shit.
Mm-hmm. All 924 pixels or whatever you said it was.
Yeah, about that much.
Mm-hmm. So I know the Adafruit's got a really good write up on that.
I know it's better than just giving up and then just letting these bags of LEDs just collect dust.
Right. Right. The Adafruit gives you a pretty good breakdown on it. Want to well, and it depends on your strings. How many per foot type of situation? If you got 60 per foot or 30 per foot, or no, 30
Is
per string or 60 per string, I think it was.
these are 60.
Right. Okay. So you should be able to break it down from there with that article. And then, of course, they give you the worst case scenario where you're all white light, which means every pixel is full blast all the time, which is your nastiest amperage you could ever draw. And then I don't know if you got into the power saving articles, which actually tell you, well, 50% looks just like full bright. 35% looks like 50%. It's really weird, but it's really a well written article about it. And then your power requirements come down dramatically because 100% nastiest fucking thing you can do is going to give you the 32 amps that you think you need. And by the way, from the first string to the second string to the third string, you're going to see a degradation in your light. That's why they do the power taps between the strings. The voltage has to be supplied at the new on the new strings. And that's the whole thing about that. If you're trying to supply it off of one point on the string, you're never going to be able to get the last pixel to light as brightly or light at all, possibly, because all of it's been consumed.
Yeah, just say maybe halfway down the total run some power injection.
Mm-hmm. I would run injection on every string at the start point.
Into every
I
string.
Yeah, you've got 60 pixels in a string. At the start of that stream and at the end of that stream, that's where your injections happen. You can run that all out of one power supply, by the way.
Yeah, it's just
It's the wiring that goes with it.
that's not going to be able, that much wire is not going to be able to fit into these aluminum channels. That's going to be the problem, is not enough space to run that much wire. At that point, there's going to be so much wire, especially at the end, the front end of that run. There's going to be so much wire in the way that you're not really going to be able to see the LEDs.
Eh, you're thinking out. You're thinking wrong. How do I explain a parallel feeder? You're not adding more wires from the single source. You're actually piggybacking off of the source along the individual strings. So you're still going to have a problem with some dropout because of resistance. Oh, this is an engineering issue. I'm dealing with this right now at work. And I'm trying to remember how we deal with this. It's kind of like how we deal with the grounds. You have you have a source point, you have an end point, but you'll have multiple points that may be coming from a single source. So you have to have a distribution block. Distribution block will be rated to handle all of the amperage. Um, Ideally, you would have separate power supplies placed along the run, which is not how it works in aviation. You have a single source. So that single source has to have the capability of producing and supplying the total current. It's just not all coming. This is where electricity is really fucked up. It's not all coming from the same source because you have split it out, and each point is a source. I don't know how the hell I'd describe it or display it even. It's the same thing that happens in a residential building. How you distribute power from through the house from a breaker. You have a big backplane breaker panel that's got all of this amperage that goes into it and individual breakers for each feed. It's the same concept. How you distribute it is how you balance the load upon the source. Of course, with a residential property, you've got 150 amps or 200 amp service coming into the house at 220 volts in the United States. And you split it up on a service panel with the different breakers. So we need to break that down into how we distribute 28 volts or 12 volts or 5 volts across a certain stretch. Anytime you're dealing with DC voltage degrades very quickly over a stretch. That's why they don't use it to distribute power, because you're limited to about a half mile from the source. This was Edison's issue with his solution to lighting. I watched a video on it last night. Edison's solution to the problem was create a power station in every block, on every block in a city, to supply DC voltage. Because DC voltage was safe. It wouldn't kill you, which is bullshit. AC voltage is much more efficient on its transfer over long distances. That's why you see the huge overhead power lines that are running at 1.5 million volts now in some areas, especially the transfers from the dams, the power stations, and whatnot. Okay, are you following me? I don't think you are. I think you're lost. So, what happens is you have to transform that AC power feed into a DC voltage, which is done through a transformer. That's where your power feed that you're dealing with is coming from. Your wall wart is producing DC energy. DC energy is really good for LEDs because it's on all the time in a straight line. AC is on and off in a cycle. And that's why they call it AC, because it changes direction, as they call it, but it's not really changing direction. It's a sine wave that does this. Okay. When you transform that into a DC voltage, you've got loss. You got heat. You can get around it with a bridge rectifier, and that's what most converters for AC to DC do. And then you get a ripple current. And the ripple current, you have to smooth that out too, and you use a capacitor network to do that, which gives you a flat line voltage regulated voltage. So most LEDs will light between 3.3 volts and 2.9 volts. Red being 2.9, blue being 3.3. In other words, you've got to supply a steady voltage of 3.3 volts to your LEDs for sure. Preferably 5 volts, because most of them are regulated internally to accept that voltage. When you get a raw LED, that's a different story. When you're talking about the NeoPixels, those things are self-regulating. They have a little microcontroller in them. They're going to cut off the excess and they'll be fine. So, yeah, that's exactly the correct face to make, sir. But I'm getting into the really nitty gritty technical shit. What you've got is already good. You just got to supply the correct voltage to it, which means for that stretch of 924 pixels, you need taps at each point where a new stretch starts. And you just need to supply that voltage. So, here is my thoughts. Tie all your grounds together within the system, because they all have to be tied together to make the control work properly. The grounds are, of course, the return lines. And that can all be done through basic wiring bullshit. And we can work that out. The rest of it is supplied whatever the voltage you end up having to need at each starting point of each stretch. This is where I need to get into this more. I that's where I'm that's why I wanted to do this because I'm thinking through this at this point on how to do this fucking project. Now, do you see why I subjected you to this torture?
Not entirely.
um, well, I'm not going to do anything as extensive as yours is, but I want to be able to do it on a smaller scale, and it still is under the same constraints that you're dealing with. So, fuck. I need to actually start making this happen in real time, which I'm not going to do tonight. By the way, this keys into my work, so self-serving, if you will. Hmm. I'm not sure where to leave this. I will tell you, keep paying attention and reading all of the Adafruit shit, especially that. Pay attention to the WLED because there's some stuff in there that's really good. I don't think this was a lost cause, by the way. And like I said, this wasn't going to run that long.
I just don't want to blow up my house.
No, you're not going to blow up your house. That's you're using DC converters. You're unless you're running a 1500 amp DC motor, you're not going to have any problems. And by the way, you're not running a 1500 amp DC motor. I don't know anybody that actually runs one of those anymore. They all run three-phase AC motors. Maybe that's what we go to. I'll have to think about that some more. By the way, I won't torture you with three-phase because that's when it gets really weird. That's when you start crossing Latinas with Oriental chicks, and then
Uh,
through it and Muslim. Yeah, those actually are probably pretty true statements or true statements with your pictures. Yeah. Anyway, you know what? I'm gonna close the live stream off, and we can continue to talk because this got
I'm
no traction whatsoever.
I'm getting tired.
Well, and I'm ready to get something to eat and go to bed too. So,
Yeah, I've been up since 4:30 in the fucking morning.
oh really?
Yeah, they want me to come in at 5:30.
Huh. Well, I get up at 3:30 to get there by 5, so I got no sympathy for you, bitch.
Well, I can get a job where it would take me about that time in order to get to work, as it'd be an hour drive.
Ugh. I'm not encouraging you for that. Mine
Eh,
is 6 miles away, and yeah, still takes me 20 minutes to get to work.
Well, the alternative would be to rent a place near the job where the building is, but that would end up being really stupid. So I'm
Hmm.
probably not going to do that because I don't think the job would be that worth it.
Oh, if it ain't gonna pay, it ain't gonna pay.
It would be like 20 something an hour, I guess.
Dude, I make $43 an hour.
See, now that would be worth moving just to a temporary place closer to the job site so I don't have to drive an hour and a half to get there every
Right?
day.
But this is what you need to understand. $43 an hour in Seattle is literally minimum that I need to maintain my lifestyle. My lifestyle is minimal, even with my drinking habits, so I can do it pretty effectively. If you were to include a woman or a child, or a woman and child, I would be so fucked it's not even funny. And I've gotten rid of the ex wife and child support payments. So, yeah, it's kind of rough at $43 an hour in Seattle area. Where you're at, mm, that would actually be really living good. That's because that's like $83,000 a year.
Well, that's before the death tax.
Mm-hmm. Yep.
I'd still live here. I would just improve the building.
Mm-hmm.
I'd reinforce the mailbox instead of using a cheap one. I'd probably try to get a better ISP,
You're not
and
on fiber?
I am.
What's your rate?
I don't know. I'm
Your
not the
mom.
one that controls it.
Yeah, your mom pays for it.
And then I'd
Yeah.
probably install a new TV in here, rearrange the room, probably get this bed out of here and get it moved into the other room so I can make this room the office. And I had more room to jump around so I don't accidentally throw myself headfirst into the wall and put a dent in the wall because I've already done that. Between that and BBs, because I've shot a pellet gun in here, which was stupid. I had to fix those. I had to buy the spackle and then fix the wall and then paint the wall. And then I
Dumbass.
also had to cover up I think it was like, what was it, the fart residue that was on all the walls because of a certain somebody. Because there was a very ass smelling residue on the walls in here after she was expunged.
Young and dumb. You lived and learned.
Her butt was just big. That's it. That's all that was learned was her butt was big and it was not a good idea.
Mm-hmm.
I mean, punching her in the back of the head to get the point across probably didn't help, but eh, it got her to get away from me for a few minutes.
Well, the only reason to punch anybody in the back of the head is when your dick's in them.
I guess she was trying. I mean, she had her back to me. pinning me to the floor with her ass that probably weighed 80 pounds by itself.
Well, see, that's just self-defense at that point. Yeah. Anyway, let's get off this discussion. You get out of here. I'm going to get out of here. I'm going to close this live stream off.
All right.
We've got some better ideas. We've got a little bit of leeway on that. I need to come up with a better structure to doing the LED thing. And I can do that now that I've got some ideas. So anyway, take care. Get
Okay.
out of here.
Just don't get involved in any of this.
No, hell no.
It's bad.
In fact, we were discussing that about one of our new production control idiots. He's
Production
not a,
control idiots.
yeah, he's not a Furby. Well, he is a Furby, but anyway.
That's not good in per se.
I'm talking like the animated toy Furbies.
Oh,
Yeah. It's still not good.
those things are creepy.
Yeah, that's what I'm getting at. Yeah, he's not a furry, he's a Furby. So there's difference.
So he's creepy, short, and hairy.
He's bald with a beard and a twink. Anyway,
Ugh. All right.
yeah. And he's still hooked on chicks. So I don't know how to place this
Gives
guy.
and takes at the same time. Okay.
Oh yeah, I'm thinking he's got a cock in his ass and one in his mouth, but he's got his in some bitch. So yeah.
Sounds like some Sodom and Gomorrah stuff.
Oh yeah. Oh yeah. Mhm.
That's bad. So I'm gonna go away now.
Yeah,
I'm just
run.
gonna turn off OBS. I'll just turn the whole camera off. All right. Well, I'm gonna go get some sleep and then go do some math after that to help me get a better idea as to what gauge of power supply I need to use.
Well, and like I said, use the formulas on the Adafruit because that'll give you what you need. Do the injection points. You can get a lot of small power supplies to do it. And they can all be wall warts. That's the beauty of it.
Okay.
You just gotta connect all the grounds together, which is no big deal.
All right.
Grounds can be small gauge.
Smaller gauge than the rest of the
Then the
wires.
feeders. Yep. Then the feeders.
Yeah.
Yep.
Whatever.
All right. Take it easy, man. Talk to
Yep.
you soon.
All right.
Night.